On Foundation 7, we're going to use the overlapping segments conjecture and the segment addition postulate conjecture to solve problems. And these are really big names for really simple ideas. So we're going to dive right into a problem and then talk about what those postulates and conjectures mean. So we're given the problem A, B, and C are collinear in that order. Before I even do anything else, I'm going to draw out a line and mark A, B, and C on that line in that order. And then they tell me, hey, AB is 7 and AC is 13. So if I mark that in my picture, I get something like this. And they want the length of BC. And most of you are already sitting here and you're going, gee, 13 then has to be 7 plus x. Or maybe you're a step ahead and you're thinking, all right, I'm going to do 13 minus 7 to solve for x. And that's what the overlapping segment conjecture is. If we know this part and we know this part and we know the whole thing, we can figure out the missing pieces. The segment addition postulate says, hey, this much plus this much has to equal the length of the whole line. Again, a really basic idea. Most of you have understood that concept since early childhood. Now you just have a fancy name for it. We're going to do a few that get a little bit tougher. So again, we have A, B, and C, collinear in that order. This time AB is 6x minus 3. BC is 4x plus 5. And AC, so the whole thing, is 32. As soon as I'm able to visualize it, it's really easy to see that, hey, all I need to do is say 6x minus 3 plus 4x plus 5 equals 32. And now I'm just doing algebra. I can combine like terms. Subtract my 2 off. And solve for x. That was one thing they wanted me to solve for. They also want me to solve for AB. So I can do 6 times 3 minus 3. Well, 6 times 3 is 18. Minus 3, I get 15 for AB. In my third example, we're putting algebra in all 3 parts now. So I'm going to have A, B, and C. AB is 2x plus 7. BC is 4x minus 3. And the whole thing is 3x plus 16. Again, once I have it all written out as a picture, it's really easy to see that, hey, I can just add my parts and set that equal to the whole and then solve for x. I'm getting 6x plus 4 when I combine like terms equals 3x plus 16. I'm going to subtract the 3x, get 3x plus 4, and then subtract my 4. And now x must equal 4. They asked me to also solve for AC and BC. I'm going to solve AC first. So I'm doing 3x plus 16, except now we know that x is 4. So I need to do 12 plus 16 and get 28. And then do the same for BC. 4 times 4 minus 3. And get 16 minus 3, or 13. These next 2 problems get a little bit tougher because now I've got 4 letters. But they're always going to tell me, hey, A, B, C, and D, with AB equaling CD. So those segments are congruent, their lengths are equal. I'm going to mark that they're congruent with little vertical tick marks. And then they tell me, all right, BC is 3x minus 3. CD is 2x plus 4. Well, since I know CD, I also know AB because they must be the same length. And then the whole thing is 33. Just like with before, I can add up my 3 parts and set them equal to 33. When I combine like terms, I get 7x plus 5 equals 33. So 7x equals 28, which means x must equal 4. AB then is going to be 2 times 4 plus 4, or 8 plus 4, 12. And then lastly, I'm looking for BC. I can either do 3 times 4 minus 3, 12 minus 3, 9. Or I could have said, hey, the whole thing's 33. I'm going to subtract 12 off twice, and I still get to 9. This fifth example is the exact same thing, except now I'll have algebra on both sides. So I'm still going to start with my picture with A, B, C, D in that order. I know AB equals CD, so the lengths are equal, which means the line segments are congruent there. AB this time is 4x minus 2. That same value can go in for CD. BC is going to equal 3x plus 5. And then the entire length is 3x plus 17. I'm going to go ahead and add my parts. And set that equal to 3x plus 17. Combining like terms, I get 11x plus 1 equals 3x plus 17, which means 11x equals 3x plus 16, and then 8x equals 16, so x is 2. CD then, I've got 4 times my x value 2 minus 2, so 8 minus 2 or 6. And then I want AD. I could solve all three parts and add them up. It's probably easier and faster to do 3 times 2 plus 17, 6 plus 17, 23.